Hello, and welcome to the EA523 Capstone project presentation by Alan Miller. This presentation shows my proposed solar and storage project with its operations and maintenance plan in order to maintain a happy customer enjoying the benefits of solar energy for years to come. As for some background on the client, they are located in Houston, Texas, and reached out to my solar company after the recent blackouts in Texas due to the winter weather, and they want to explore the option of going solar, specifically with adding battery backup. My client is very energy conscious, and they bought an ENERGY STAR certified home, which saves up to 20% on electric bills compared to a new non-ENERGY STAR home. And all appliances in this home are electric. There's no gas appliances, so your stove is going to be gas, your HVAC system is going to be your stove is going to be electric, and your HVAC system is going to be an electric heat pump versus a gas furnace. This home is pictured to the right, and the property line is highlighted in red. Again, it's in Houston, Texas. And due to being a new neighborhood, there are no threats of shading from trees as the surrounding land was clear cut, and new trees have been planted in the yards, but these will take decades to grow large enough to cause an issue of shading. The roof pitch is 4/12, meaning every 12 inches horizontally, the roof rises 4 inches vertically, and this equates to roughly an 18.4 degree tilt of the system, of the panels. The home faces east and has a hip-style roof, so each side of the home has roof that faces that direction. The main concentration of panels will be put on the section of roof facing south, with some placed on the front east-facing section. And Houston, Texas is energy deregulated, meaning energy customers are able to choose the provider of electricity in order to prevent monopolies. Our customer has already picked a provider that allows them to connect to the grid and store some of their energy. There are two incentives available to my client. First, they are eligible to participate in the National Solar Investment Tax Credit Program, which currently allows 26% of the cost of the system to be deducted on federal taxes for systems installed before 2021 ends. Locally, Texas has the Renewable Energy Systems Property Tax exemption, which allows an exemption of the amount of 100% of the appraised property value increase arising from the installation or construction of a solar or wind-powered energy device that is primarily for the production and distribution of thermal, mechanical, or electrical energy for on-site use and devices used to store that energy. For the load analysis, my client has provided a list of appliances that they have that use energy, and this includes the HVAC equipment, water heater, dishwasher, refrigerator, lights, the stove and oven, washing machine and dryer, television, electronic device chargers, and fans. They've also provided their energy usage per month in 2020, shown on the table here. And it's broken down the kilowatt used and the kilowatt hours per day, totaled. And to find the watt hours per day, I took the total kilowatt hours used of 10,707, divided that by the number of days, and converted to watts by a factor of 1,000 watts equals 1 kilowatt. And this gave me an exact number of 29,334 watt hours per day, compared to the averaged 30 kilowatt hours per day of use, which would have been 30,000 watt hours per day. We just wanted to be a little more exact in our analysis. So we needed to make some assumptions. And these are the days of autonomy, the depth of discharge, and the safety D-rate factor. And so we have 1 day of autonomy, where the system can provide 1 day worth of electricity in the case of another blackout, and a 40% depth of discharge to help extend the life of the battery, as you never want to drain the battery all the way. And for the safety D-rate factor, we found that the average low temperature in Houston, Texas is 40 degrees, and from the safety D-rate factor chart, that temperature equated to 1.3 of the safety factor. And then we took the watt hour per days, multiplied that by the required days of autonomy, then divided by the depth of discharge to give us 73,335 watt hours, which was then multiplied by the 1.3 safety derate factor, and lastly divided by the volts of the battery to determine the amperage of the battery system. For the system design, the storage system will consist of 2 strings of batteries, each string consisting of 4 12-volt 1040 amp-hour capacity batteries. Each component, as well as its location, is depicted on the table below. PV panels will be located on the roof, while the charge controller and inverter will be on the exterior of the home near the utility meter, and the storage system will be located in the garage. Our system will need to be sized to produce roughly 11,000 kilowatt hours of electricity to meet the client's 2020 demand. In order to maintain the system through its life cycle, our client will need to follow an operations and maintenance plan. We have laid out a plan for them, as well as provided detailed information about what exactly an operations and maintenance plan includes. The next slides we will discuss commissioning, considerations, operations and maintenance, the owner data collection, third-party services, and a timeline of maintenance. PV systems need to be commissioned if one is planning to be installed. This is a 2-step process that takes place when the system starts operation and again after 1 year of operation. Commissioning is the overall process of installing and inspecting the system before use. When commissioning, electrical, mechanical, and other safety items need to be checked. Electrical items include checking that all disconnects are off when inspecting, the installation matches design documentation, all equipment is sized appropriately and is in compliance with the local authority having jurisdiction and the National Electric Code, making sure terminal connections are secure. Mechanical checklists are shorter comparatively and consist of making sure all the equipment is securely mounted, any roof penetrations are sealed, and the installation meets the manufacturer's specifications. The first step when starting the system the first time is to connect power sources to systems. Next, the DC voltage and polarity needs to be tested. Third, the AC voltage at the inverter output needs to be tested. And lastly, conduct the startup procedure. After the first year of use, the entire system will need to be commissioned again as a requirement. One of the first items to consider is to select maintenance alternative equipment that requires little to no maintenance. Although there is a high upfront cost, these pieces won't need to be replaced as often. Another strong setup is to use network connected inverters, allowing for remote testing and updates. As mentioned above, commissioning the project by a third party creates a strong foundation for a successful operations and maintenance plan. The geographic location of the system needs to be considered as well. For example, if the system is located in an area susceptible to hurricanes, which Houston, Texas is, further steps will be required to lower the risk of operating the system in that region. And some of these include using through bolting as opposed to a self-tapping screw. You will need to use stainless steel boxes with thick rubber gaskets and multiple closure attachments so that they will stay intact and exclude moisture. And the boxes and conduit runs will need drainage to provide in case of water infiltration. For best practice, further monitoring and maintenance on the system needs to be conducted beyond commissioning. These can be broken down into 2 categories, PV operations and PV maintenance. PV operations include 5 areas: administrative operations, conducting operations, directions for the performance of work, monitoring, and operator knowledge, protocols, documentation. Administrative operations means having documentation of the system, including but not limited to plan drawings, inventories, owner and operating manuals, and warranties. Having these on hand and accessible is key when an issue arises and the information is readily available to work towards the solution. Conducting operations consist of making sure qualified professionals are operating any maintenance on the system to ensure safety of the workers and the owners. Directions of the performance of work means the system is safely maintained by qualified professionals. Monitoring is keeping an eye on the performance of the system to benchmark their performance and highlight any anomalies. And the last area of the operator knowledge protocols and documentation is to provide safe and reliable operation of the system. PV maintenance is broken into 4 types: administration of maintenance, preventative maintenance, corrective maintenance, and condition-based maintenance. Administration of maintenance involves budgeting for maintenance and contracting the right provider for maintenance on the system. Preventative maintenance involves keeping the equipment maintained for optimal performance. For example, this would be a roof-mounted system, so you would want to make sure that the panels are clean. Corrective maintenance is fixing equipment when there has been an identified problem to fix. And condition-based maintenance is very data-driven and requires a watchful eye on the performance of the system and can identify future problems. The following documents and procedures will need to be kept or monitored by the homeowner. Administrative operations. Our client has agreed to keep the plan drawings, owner manuals, and warranties in case any future third-party contractor needs this information when working on the system. The homeowner will also be in charge of conducting operations and hiring professional third-party contractors to perform any needed work on the systems. Directions of performance will be monitored by the homeowner, but again, any maintenance will be performed by a qualified contractor. Our client has agreed to monitor the performance of the system and have a service provider on call to reach out when any performance issues arrive. As stated above, any maintenance performed on the system, whether it be preventative, corrective, or condition-based, needs to be performed by a qualified third-party contractor. Administrative maintenance will be completed by the system owner, budgeting for any required maintenance as laid out in the plan. They will also need to budget for any unplanned maintenance, as you know, things just happen and items break. We have provided them a list of qualified technicians who can work on the system. All of these contractors are experienced and either licensed electrical contractors, NABCEP certified, and have working knowledge of the NFPA 70, the standard for electrical safety in the workplace. Sorry about that. And we have created an outline plan of maintenance to be performed on the system, both visually by the owners and for those that will need a qualified electrician to perform the work. So quarterly, our homeowner will check for shading and the cleanliness of the panels. Yearly, the homeowner will visually inspect the panels from the ground. They will visually inspect the panels and mounting structure. Also yearly, they will have qualified personnel out to check the wiring, connections, and the system voltages. Every 5 years, they will again have a third-party contractor check the integrity of mechanical conduit and insulated wires. Any maintenance that is corrective will be done on an as-need basis. We hope this presentation has been very useful to our client in their solar power journey. Thank you.